Well, it's not like they have.
Okay, so I want you to do this by. What's the day after spring break? I mean spring break. I'm already in spring break. That'd be awesome. We come back on the Monday, right? After fall break. Woo! So excited. This is like our first fall break ever, right?
Yeah. In the history.
Yeah, right? I'm so excited. Okay, so the 20th, October 20th. Wow, I'm not gonna see you guys for a long time.
Yeah? So that's due October 20th?
Yeah, so I'm giving you guys 4 assignments.
Whoa.
But you have 2 weeks to do it.
What?
1 week.
No, because this week.
Midterm.
Midterm.
Okay, fine. But.
Oh, I thought you were like, okay, fine, I'll take off.
No.
Yeah, I know, right? You said, okay, fine.
And then some of us are going to be on the trip.
Yeah.
TBH.
Oh yeah.
I'll be like,
like
we're
a
going
whole
college
weekend.
North.
That's you're asking for all that in one weekend.
So that's why plan ahead. Start this week. Start tonight.
Even if there's
Yeah.
we actually have
You
the
gotta
study
plan it out a little bit every
No one-
day.
no
A
one's about to
little
do it.
bit every day. How many of you guys are going on the fall thing? I mean the trip. Perfect! You guys can have a little calculus study group. On the bus, what are you gonna do all those long hours? Calculus. Why are you gonna sleep at
We gotta
home
wake
before
up
you
at
go?
6, or we gotta be there at 6. Long hours.
Okay, so that way when we get back, we're gonna hit this, and then we're gonna do this, and then we'll be ready, and we'll be in good shape. Okay? So you guys already know chain roll, so just more practice on chain roll, and then you guys are gonna learn implicit derivatives today. Wonderful. Oh, okay. I'm also gonna pass out. Now this is all gonna be on like this class right now is on the video, so of course you can speed through this if you're gonna watch the video. But I just wasted paper. I mean, not waste. It's a good use of paper to print out a practice multiple choice part of the mixed room for you guys. Okay. I don't have the answer key. I was debating whether I should give you an answer key. Okay, you guys can do this. Just take 6 pages and pass it down. Take 6 pages and pass it down. Okay? It's the 6-page practice test. And I'll pass around the stapler. The stapler might be broken. If it is, you can help me fix it. This paper, it's like a stack of paper. My student, my first year of teaching, like 6 years ago, gave me like a bunch of school supplies, including this really like weird computer paper.
You guys need this?
And I used it. I mean, I'm finally using it.
Paper that comes inside like workbooks. Yeah.
Yeah. This is like a nice heater. Okay, so you guys know that there's going to be FRQ and multiple choice. However, this is just a practice multiple choice. I don't want you to think of this as a comprehensive practice test though. Doesn't mean that this is the only stuff that's going to be on it or it's going to look only like this. But this is just, just a fun opportunity for you guys to review stuff. But if you want to something more comprehensive, you have to look at that topic list that I put on Schoology. Okay? On your midterm?
Tomorrow.
Let's see.
That's it, tomorrow.
What about the weekend?
SAT on Saturday.
I can't answer that question right now, actually. I don't know. It's something like that. 30 questions and then some FRQs.
You said today's the only day you're available for tutoring?
Yes, right, because I am not going to be on after school. Oh, shoot, I didn't prepare. Okay, let's turn to this page. I really hope you guys have been keeping track on top of your homework and you feel comfortable with chain roll because we're going to step it up and add some other stuff to the mix today. So I don't want you guys to get too lost. So it's very important that you keep, you know how math builds, right? And so if I'm building, and we did level 1, and then we're now doing level 2, but then after that we're doing level 3, but if you never perfected level 1, you're going to be very confused on level 3. So stick with the building process. Did everyone use it? Did everybody get the practice exam? I'm debating whether I should put the answers up. I think I will. I think, I feel like my teachers never do that. They're like, here's some questions. And then we were like, well, I'll freaking out over it. But I think I'll give you guys the answer key on Schoology, okay? Did I take attendance? Yeah. Just to make sure.
So
All right.
the first ones and the first and last one are kind of the same thing, just the variables change. Right?
This one? Oh.
First and last one.
Yeah.
And then the middle one is the shortened version.
Yeah. So. Okay, you guys ready? All ready? No, we're not ready. He doesn't have his notes out. I don't know what he's doing or where he. Okay, good. Okay, so before we do implicit, the point of the goal of today is implicit differentiation. But before we go there, we're gonna take a little sidetrack and talk about the definition of the derivative, because you'll see this on maybe your midterm and also on the AP test, where sometimes they're just testing your knowledge of the definition of the limit definition. The limit definition of the derivative, right? So these are three ways to say the derivative, right? The derivative f prime of x. This is the derivative function. Let's call this the derivative function. And this one is derivative at a point, right? So this is just generic x, and this is when you plug in an actual value, an x value. So what is the difference? So this one is a traditional definition. H goes to 0 of f of x plus h minus f of x over h. What is this one? This is x minus f of x minus f of a over x minus a. Yeah, this is the alternate definition. This is the alternate definition. So you need to know all of these. This is also at a point. Okay. All right, so these look familiar to you, right? Nothing is shocking. Based on our vast knowledge of the power rule, because now you guys are experts at the power rule, find the value of the following. Okay, first rewrite as a derivative. So, on an exam, if you see this, and you're like, whoa, I have to calculate the limit. Yeah, you can calculate the limit, but that's a lot of work, and they're not asking you to like expand that and all that. What they want you to recognize that this is a function of x, some function x plus h minus that function over h. So when you see this, you should recognize, hey, this is just the definition of the derivative. You see that? What about this makes you realize that this limit is not just any old limit, but it's a derivative? That there's h, would you still recognize it if it wasn't h, if it was like m, and this was the limit as m goes to 0? It's not the h in itself. It's the format. It's the x plus something, and then the second, and then you're subtracting, and this is just some x, and then over that something, and then that something is the limit of that something going to 0, right? So that should help you realize, hey, that's some function. That's a derivative of some function. But what is the function? The function is an x squared function, right? You see how it's apparent here that it's an x squared function? They're not going to say f. They're actually going to put in there what f is. F is x squared. So that should tell you, oh, that's the derivative of x squared, which you don't have to do this anymore. You know how to do the derivative of x squared. What is it? 2x. Get it? So now we're kind of going backwards. Now when you see the limit, you're like, I don't need to do the limit. I know what this means. I know what you're trying to say. And you could do the derivative. Okay? So let's try another example.
So we just grab the function and put it into the d.
Yes. So here, okay, now this one is, it's not going to 0, but you can tell that this is the derivative again, but this is using the alternate definition, right? Because this is something, okay, because you know what? When you see this, 25 is also something squared, isn't it? So this is something squared, x squared minus a number squared over the x minus that number as x goes to that number. So you're like, hey, this is the alternate definition. It's the derivative of a function. What's the function? X squared. But this time, it's not just some a, They actually plugged in what? 5. So this is the derivative of x squared evaluated at, that's how you say it, evaluated at x equals 5. At that point, x equals 5. So that means the derivative is 2x. So this is what you guys do. You guys don't plug it in until the later. So you do the derivative of x squared is 2x, but at the end, once you found the derivative, you plug in 5, and then you get 10. Okay? Okay. So let's try this one now. What is this? Which definition is this? It's the derivative. Is it the first, second, or third on the top there?
At a point.
It's the third one though, because it's at a particular point. So this is something squared minus something squared, huh? It's 5 plus h squared minus 5 squared, right? So that's the derivative of, are you going to put 5 squared? But if you put 5 squared, the derivative of 5 squared is 0. So you're going to say this is x squared. Do you see how that's important? Where's the baby? No, we're not doing the derivative of this. This limit is telling us to find the derivative of this at x equals 5.
So then it's going to be 10 again?
Yeah. Yeah. Okay. So erase that.
Oh.
So what this really was the limit as h goes to 0 of x plus h squared minus x squared over h. Now if I say that, which really is the limit as h goes to 0 of some function okay. Do you guys agree that this, what is here, is the same? If I just replace the 5 with x, that this is just this?
Yeah.
But here, but it's all of this, but just assuming that x is 5. Right? But before we plug in x equals 5, it was this, right? And this is just this. Do you agree with that? It's just that what is the function? X squared, right? Because if this is, okay, we know this is the derivative, right? And if I just let f of x be x squared, then I would plug this in x squared, right? X squared, yeah?
So we can always figure out the function just by looking at the second part, the minus.
I guess so, yeah.
And whatever, because that's just f of x.
Well, we'll try some more examples to see, okay? Now, I knew that x was, how did I know that x is 5 though? Because this x became 5, and plus 25 is 5 squared. So those two clues tell me that this function is being evaluated at x, or this limit is being evaluated at x equals 5. So, but we know that the definition of a limit, this definition of a limit is for the derivative. So this is really the derivative of x squared at x equals 5, which is 2x, which is 10. Is that okay? No? This is, I know this is tricky. It always trips people up. I think my first year I forgot to like teach this, and then it would just show up on the midterm. Oops. Okay. What about this one? So we know something, huh?
Okay, the x squared.
Here?
You got that from minus x squared right there, right? Or how did you get that?
This one?
Yeah.
Okay, good question. She wants to know, how did I know that this function is x squared? it's not, I mean, okay, Josue was saying, yeah, you could often look, if you just look at this will tell you what the function is. Because look, the function here is often just right here. But it's because the limit definition tells you it's the limit as h goes to 0 of some function, but the argument of the function is x plus h, and then you subtract just regular f of x, right? So this is where my f of x is going to be, and this is going to be my f of x as well, but you're just adding h to the argument, to the x. Well, look here. This is my, both of these are something being squared. So I know my function is a squaring function. The only thing is here, what am I squaring? Here I'm squaring x, but here I'm squaring x plus h, which is what I'm supposed to do for the definition of the limit. So yeah, I guess if you want a trick, looking at this will tell you what the function is. This is the function as well, but in this spot, this is x squared. This function is x squared, right? Right? This is x squared. But what do you put into the input into the function? In the first spot, you're supposed to input x plus h, and in the second spot, you're supposed to just input regular x. And so, looking at both of these, you know that the function is x squared. Okay. What about here? You know that this is the alternate definition, the second one. Okay. Here I have a clue. 27 is 3 cubed, right?
But then,
Huh?
I was just gonna say like, since it's the alternate definition, you already know it's 3 since x is equal to 3.
Yeah. So really this is limit. Oh, that's true. But sometimes maybe it's not an alternate limit. Maybe it's just a regular limit. If I put the limit as x goes to 4 over here, that doesn't mean it's a derivative at x equals 4. It could just be just a regular limit. It has nothing to do with derivatives, right? So look, you have limit as x goes to a of x cubed minus a cubed over x minus a. Isn't this the same thing here? This is the same thing, but every spot where I put a, what did they plug in?
3.
They plugged in 3, and that's confusing because it's also a cube function. They did that on purpose to confuse you. But you know what this is. What does this really, what is that?
Alternate.
That's the definition of a limit, an alternate definition of a limit. I mean a derivative. So they're asking you to find the derivative of what function?
X cubed.
Let's look. Yeah, of the function x cubed, except x is going to be evaluated at 3. Is everybody with me?
Yeah.
What's the derivative of x cubed?
3x squared.
3x squared. And if we plug in x equals 3 there, we're going to get 3 times 9, which is 27. Okay? All right. Why don't you guys go ahead and in your tables try the next few on your own. Next few. So now try the next few on your own. Okay. Oh. Here, you can use this one.
Does the function is your x
What?
No, it's the question.
Yeah. You kind of have to learn how to think backwards for this. Did Mario get it? Doesn't he crack you up? Uh-huh.
Yeah, they both do.
Yeah. Yeah, the twins. Are you working? No, you're not. Come on. plugged in a value here. This is supposed to be x plus h equation, and this would be x, but there it's not x. It's supposed to be x squared, but they
I don't know what this is.
5.
What is this?
See? Because what divided by what squared?
X would be this value because they plugged it in.
Here they didn't plug in anything.
That's what I
So
got. And then
there
the
is no.
second one I got.
There is no.
I got one.
X equals what?
2x squared.
There's no.
That's me plugging extra x.
Oh, what do you get? It's the 3?
That's a thing, x.
There's no
So that one's like the first example, the very first example.
Oh, yeah.
There's an answer.
No, it's just like.
Oh.
Is this one just like
I got one.
f prime of x? Wow.
Yeah.
Oh wait.
Function is x, yeah.
This one on the other hand. Oh, this one's like.
I'm gonna go ahead and put the answers.
This one is
So you can check.
So you can't find the like the equation from here,
Yeah.
and then you find the derivative.
Yeah, just make sure that the other part is accurate, otherwise it's not a derivative, it's just a regular random
So we're trying to
limit.
find the function and then we compare it to the
Derivative.
You get the derivative of 5.
Is that it?
That's the derivative.
Yep.
No, it's not. It's not the alternate. That's it. You only do x at it. No, it's the alternate or the point.
Ooh, okay, so 5, 6, this is 5,
And
4.
20. 5. Oh,
It's exactly right here.
No.
No? Oh.
Because look, it's 2 minus 3. Or minus. Because remember you have to do f of x plus h minus all of f of x, right?
Yeah?
Yeah, I got it.
So this has to be a minus over here, and if you want this to be a minus, then you have to factor. You have to factor out the minus.
So it's minus 6?
Yeah.
But I thought.
Wait, why is it
But
minus
no,
6?
but the function alone is just 2x to the 4th. It's
No.
just when plugged into the equation.
No, because it's because
it's
there's a
negative.
negative in front of the 2, so like.
Because if it was plus, yeah, because it has to be whatever the function is of f of x plus h minus f of x.
Which is just the original
So,
function.
okay. If this was the function, right?
Uh-huh.
Then when I subtract it over here, then it would be minus 2x to the 4th. It would be minus this, right? So then that would be minus 2x to the 4th minus 3x squared. But it's not minus 3x squared, it's plus.
So which one's wrong?
So this is wrong. So if it's like this, then you know that when you subtract it, then you're going to be Oh
Then
shoot,
you
shoot,
get
shoot, shoot.
an X, yeah.
You're gonna get negative 2x to the 4th plus, which is what happened.
Oh, so that's how we simplify it.
Yeah.
So it's my,
So this is all about thinking backwards, kind of.
Yeah, I did.
so low cost. Then
Is that absolute value?
Yeah. No, those
No,
are
it's not. It's
brackets.
bracket.
So,
It's negative x squared plus x. That's the function.
Okay, we're gonna have to move on, so I need you guys to write down these solutions. You could go ahead and write down the solutions, or you know what, you could get them on Schoology, but if you want, just quickly write down the solutions so you could make sure you get this later on.
I'm gonna write them down.
And I just want to point out one thing that I don't know, thought process I noticed that I did when I did this. What are you doing? That's weird. Oh. High schoolers.
We're doing implicit differentiation.
What was that? Yeah. 25 minutes. Or 30, 20, yeah, 25 minutes.
Wait, so what's the reference one?
Those 4 things.
The next 4?
Yeah.
Up to the second
So you have 2 weeks. Yeah. So up to second implicit derivatives.
we better do these over that trip.
So 36b, 36c, 37a, 37b.
So you do the 20th, right?
Yeah. 2 Mondays from now.
Hold on.
Bisca. Alright. Okay, so you know what I realized? This is what I do. When I see this, I'm like, oh hey, limit goes h goes to 0, h on the bottom, x plus. This looks like the derivative. It's probably 3x minus 2. But let me just check. If the function is 3x minus 2, over here should be 3 of x plus h minus 2. And I just make sure. Because if it's not, they might be trying to trick you. And maybe this is not even a derivative. Maybe it's just a random limit. You see? So don't just look there. Make sure the whole thing is the way it should be. Okay? Over here, oh, this is just the definition of a derivative. Aha. Okay, here, again, hey, I think the function is 2x to the 4th plus 3x squared, but then the negative throws you off, and then you realize, no, if you factor out the negative, because the definition says you're supposed to be subtracting a function, if you factor out the negative, then this is really 2x, you know, it's minus 3x squared, and it's verified here. So just make sure that you have every x, once you decide what the function is, over here, make sure that for every x is x plus h is plugged in there. Okay, and here I'm like, hey, this is so I'm like, this looks like the alternate definition, x minus 5, so it's x minus something. So what's the function? It's x to the 4th. So my function is x to the 4th. Oh, but 625 is what to the 4th? Oh, it's 5 to the 4th, which makes sense because this is 5 to the 4th and this is 5 down here. So yes, we're evaluating x to the 4th at x equals 5. Over here, I'm like, oh, wait, looks like the alternate definition. It's x cubed minus something cubed. Oh, this is exactly the definition, and so nothing is plugged in. My actual point is a. So, nothing wrong with that. A is just a constant. And then, I don't know if they did this on purpose, if this is a step function, but we're just going to ignore that. We're just going to pretend that's brackets, okay? I'm just going to assume that because I just noticed that for the first time today. Okay, so this is, oh, so the minus is already factored out here. So that means I could believe that this whole inside here is the function, negative x squared plus x. But let me make sure. Is this negative x squared plus x? It sure is, except that for every x I have an x plus h. And so there I go. Okay?
Is this a review?
So that is I told you guys earlier, that is a practice test. It's like a review, but it's not necessarily a comprehensive review. Think of it as a practice midterm, just the multiple choice part. Practice midterm multiple choice part section. But don't think, oh, as long as I know everything on here, I'm good. Do this as practice, but make sure, because this might not cover all of the topics that I gave you as a list on Schoology. So also double check with that list. Okay? Alright, so now let's get into the meat and potatoes of today, which is implicit differentiation. I really love this. It's really fun. I don't know, I think all the calculus is pretty fun, but. Okay, implicit differentiation. You guys ready? You ready to engage your brains? Stop. If I get, okay, I do this when I play piano too, but when I get excited, I start going really fast.
Okay, yeah.
So
Yeah.
So we can tell you to stop. Like,
Yeah, so let me know if I'm going too fast. Okay.
Go too
slow
fast.
down.
Suppose you are asked to find the slope of the tangent line. Okay. Suppose they ask you to find the slope of the tangent. We know how to find the slope of a tangent, right?
Kind of.
The
Yeah.
derivative.
Yeah,
It's the derivative. The derivative gives us the slope of the tangent. But what if they ask you to find the slope of the tangent to this curve at the point 4 equals 3? I mean, 4, 3. What are they asking us to do? We have to find the derivative of this equation and plug in what?
Is that the price tag?
Plug, kind of, yeah, kind. Okay, we're using what? So normally what we do is we take f of x, right? And then we find the derivative, right? And then we plug in what into the x? The point. So which is our point?
3.
But we're going to use x equals 4, right?
So you find the derivative.
We find, if we have a function like y equals x cubed, then we find the derivative of that y, which is the derivative of x cubed, and we plug in, for x, at the end we plug in the point,
So it'd be like
the x value.
In that case.
Yeah.
Okay.
But what makes this more difficult?
The y squared. There's another variable.
The y is not by itself, right? You guys should know this from pre-calculus. Maybe you don't, but this is an implicit equation. Okay, it's a circle, yes. It's an implicit equation because an explicit equation means that y is by itself. Y is solved for, and we're explicitly stating the
Y equals
function.
that.
Yeah. But implicit is when the x's and y's are like kind of mixed together and y is not isolated. Did you get that?
No.
What is an explicit equation?
Like x and
When the y is
isolated.
isolated. What is an implicit equation?
Mixed with the other
When the,
variables.
yeah, so y is not isolated. Is the y isolated here? No, so this is an implicit equation.
Can we make
And you can't.
Okay. Huh?
Can you make it?
Yes, you can. You
Subtract
could
it.
always do that. So first we can solve for y. That's making it explicit, like she said. Okay, so which is y equals plus or negative the square root of 25 minus x squared, right? I know I skipped a lot of steps, but is that okay?
X squared plus 25, right?
Yes.
Can you do like negative x squared plus?
Yeah. If you want, you can say negative x squared plus 25 to the 1/2 power. Okay? Alright. Now take the derivative.
Chain rule?
Okay.
Is it?
Can't find the square root of a thing.
What?
Oh,
Okay, so wait, hold on. So this is y. So y prime would be what?
1/2.
Plus or minus 1/2 times negative x squared plus 25 to the negative 1/2 times chain rule would be negative 2x, right?
Yeah. So you have negative x in front.
And then we're going to evaluate this at x equals 4.
So you plug in there.
Yeah. And then we're going to get, what are we going to get? Plus or minus 1/2 times, okay, 4 squared is 16. So 25 minus 16 is 9. And then the square root of 9 is 3, but that's 1/3, right? Because it's a negative exponent. So 1/2 times 1/3
1/6.
is 1/6 times
Negative 8.
-8 is 8/6. 3/2?
Wait.
Oh, did I lose you?
Yeah.
Okay.
Where'd you get 1/3?
Oh, okay.
1, 6.
Okay, well, first of all, can we cancel the 1/2 and 2?
Yeah.
Let's cancel those. And then this is a negative, so that's going to go from plus or minus to minus plus, right?
Minus. So it's negative.
Same thing. No, it's plus or minus. Because it was plus or minus, and then you multiply by the negative, so it's going to be minus or plus.
Okay.
Same thing, right? Get me?
Yes.
Yeah?
Wouldn't it be plus or minus whatever it was?
So we have minus or plus, which is the same thing as plus or minus, right? It's like a Chinese character. Okay, now we're going to have 4 squared is 16, so negative 16 plus 25 to the negative 1/2 times 4, right?
Wait, why is this? Oh, is it times negative or the number?
Now we already took care of the negative by making it minus plus.
Yeah.
Okay, 25 minus 16 is
9.
9, but the square root of 9 is
3.
3. But negative,
1/3.
Wait, why are you? Oh, yeah.
because the 1/2 exponent means square root, right? But the negative exponent means reciprocal. So reciprocal of 3 is 1/3.
What would it be? 1/3 squared?
No.
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 So it's 1/3
It's another
times 4. So that's 4/3. Okay. So the answer is going to be plus or minus 4/3. Okay. Now this is not implicit differentiation. This is doing it the hard way. This is doing it by making it explicit first.
Oh.
But clearly we have a problem. Now we have a plus or minus in our derivative. Which one is it? Okay, how do we know which one to take? Right? Okay, so the process that we have gone through is actually called explicit differentiation. We just explicitly differentiated. What does that mean? This process is accomplished by first solving for y, then taking the derivative. But suppose we were asked to find the slope of the tangent to the line of x squared plus y cubed plus y equals 2. Clearly, it is difficult or even perhaps impossible to solve for y. Do you guys know how you would go about solving for y right here? Because how do you factor that and then, like, you know what I'm saying? It's really complicated. So another technique is needed, and that is called implicit differentiation. When you're doing implicit, you don't have to solve for y. Okay? You can just straight up start finding the derivative. We take the derivative without solving for y. Okay? You still with me? Alright, so let's try it now. Let us do the original problem, finding the slope of the tangent to this curve, x squared plus y squared equals 25 at the point 4, 3, using implicit. So you have the original equation. Now you're going to take the derivative with respect to with respect to what though? With respect to x. When we're finding the derivative, we're always doing dy dx, right? We're differentiating with respect to x.
So it's
d dx, that's the derivative of whatever with respect to x. The dx on the bottom means with respect to.
Is dy dx the same thing as ddx?
Say that again?
Is dy dx the same thing as ddx?
Yeah, dy dx means d dx of y.
Oh.
Oh.
Okay? Alright, so now remember the chain rule. What's the derivative? So what's the derivative with respect to x of x squared? 2x. Good. What's the now we have a y here, but we're finding the derivative of y with respect to x. So what's the derivative of this? It's going to be 2y times, you have to do the derivative of the baby. What's the baby? The baby is y. So you have to do dy dx.
What?
Alright.
Yeah.
Your baby is y?
Yeah.
So we can put.
And the derivative of 25 is 0.
Yeah, I'm confused with that. Baby is
dy
y.
dx.
Okay. Because think of y as a foreign element, okay? Because when we're doing the derivative with respect to x, we only know how to work with x. We know how to do the derivative of x squared, 2x, x cubed, 3x squared. We know how to do the derivative of anything that has x in it. But we don't really know what to do when it's something else squared, right? How do you do the derivative when it's something else? We would always do, like we always did, and we did the derivative of the baby, ¿no?
Yeah.
See what I'm saying? if this was anything else inside.
So why don't we
If this was u inside, it would be 2u times du dx. Remember that?
So because it's x, we just
But if
leave
it's-
it at 2x.
If it's y inside, then it's 2 times y, and then the derivative of whatever y is.
If it would have been x, it would have just been 2x.
It
So
wouldn't
if
be
it was
dx
an
then.
x inside, it would be 2x times d dx. But d dx, what's the derivative of x with respect to x? You could think of it as, well, one way you could think of it as I mean, you could think of it as a fraction, even though it's not a fraction. dx over dx is 1. But also, what's the derivative of the function x?
1.
So we never did that, but technically we could have done that with every single step. But we don't. Okay?
Are we gonna, what do we have to do then on the test?
So you
For
can
this?
Kinda,
Yeah.
No.
You can kind of put like the y in parentheses.
Yes.
Okay.
Does everybody see why we multiply by dy dx as part of the chain rule? Yeah? Okay, so let's keep going. So now we can now plug in. Now we're not just going to plug in x. We know that the 4 is x, the 3 is y. Because to find the derivative, we need the x and the y. So the derivative is, okay, so 2 times the 4 plus 2 times the y times dy dx equals 0. Right? So 8 plus 6 dy dx equals 0. Just going to do this over here. So 8 plus 6 dy dx equals 0. So if I want to get dy dx by itself, what is it? dy dx equals negative 8 over 6, which is negative 4/3.
Easy.
It's easier, right?
Yeah, but
I feel like it's just shorter.
Yeah. Are you guys okay with this so far? We're not done yet.
We're not?
No.
That's not the answer?
I mean, it is the answer,
Oh.
but we have to talk about this
Oh, yeah,
problem a
'cause
little
then
bit
it
more.
gets, like, jumbo.
Are y'all okay with this? Not
What
too
if-
fast?
What if it was like
what about like if it was
If it
that
was plus
equation,
a-
the
plus
x,
another y.
the x squared plus y?
Okay, we'll get there. We'll get there. Okay, so hold on. So it says, notice that we did not actually solve for the derivative. We didn't get dy dx by dy dx is the derivative, right? It's the derivative of the function y, right? We didn't actually solve for it before we plugged in. We just started plugging in here, and that's okay, because at this point, you know, to find this, you just need to know what x and y is, and we already have an x and y. So we plugged in right there. But if we needed to, if I asked you, we'll find the formula for dy dx, we could have solved for it up here, right? What would we, if we wanted to, what could we have done? We would say dy dx equals
2x. Oh, 2x divided by 2y.
negative 2x over 2y, right?
Why is it over?
Because you would subtract 2x on both sides and then divide, right?
Yeah.
Which simplifies to negative x over y, right?
So we could do that instead.
Uh-huh.
So for number 1, that would be that would
Whoa,
be
whoa, whoa. Yeah,
this one?
hold on. We'll get there.
5 over 3.
Hold on. Okay?
Or do 16.
Questions on this? Okay, so this tells us the derivative of this, you guys know it's a circle, right? But of this equation, the derivative, which means the slope of the tangent at any point xy, is going to be whatever the x is divided by the y at that point, and then negated. That's the slope of the tangent on that circle. Okay?
So like what she said about that mama.
So that works for circles. This is a little different because this is not.
This is not a
That's a hyperbola. Okay, so hold on. Why did doing it this way give us two answers? Because at a certain point you can't have two tangents, right? One going positive, one going negative.
because it was like
Let's think graphically,
You
okay?
could at any point. Right?
So well, let's think graphically. What is this? You said, you guys identified it. That one is a circle, okay, with centered about the origin with a radius of 5, right?
You're on different sides of the axis.
Okay, yeah. So the point that we care about right here is 4, 3, right here. So that makes a 3, 4, 5 triangle, right? Like you said, Pythagorean theorem. So this is 4, 3, and 5. Okay? That's the, I don't know why I decided to do it so small. Okay, so this is a 3, 4, 5 triangle. And the tangent is this one, right? But when we did explicit differentiation, they gave us the slope being either plus or minus 4/3. Is this one should it be minus or plus?
Minus.
It should be, yeah. It should be minus, right? But why did it give us plus or minus? Because you know what? We never told them that we were at 4,3. The only thing we plugged into this equation was 4. So this equation doesn't know if you're at 4,3 or 4 -3. At x equals 4, there's 2 points that the circle has, right? So they were giving you both that slope and this slope. Because doing explicit differentiation, you don't ever have to plug in the y, right? But we want to plug in the y. And so when we see plus or minus, you should think, well, one, you should think graphically to make sure you know which exact point. Because if I give you an exact x and y value, you know that at that point there's only one slope, and that has to be negative, okay? But you won't come across that problem if you're doing implicit differentiation, okay? So now let's do some more practice. Oh wait, hold on. It says the key to doing implicit differentiation is to use your derivative rules on every term of the function, but remembering to use the chain rule on that term. So make sure to use a chain rule, even if it's a y there, you have to do the chain rule on the y. So to do the derivative of the baby, which is the y. In differentiating the expression x squared plus y squared equals 25, we write, okay, so here, see, they did it. So they did chain rule on the x and the y. So the x squared, the derivative of x squared is 2x times dx dx. But that goes to what? This is 1, right? And then 2y times dy dx equals 0. The term dx dx equals 1. It is not necessary, but it is best to put it down. Stu says it's best to put it down and then eliminate it. Frequent careless mistakes are forgetting this term. So let's do that. From now on, let's just do that. Well, at least for implicit differentiation. Okay? So let's do an example now. We have like 6 minutes. Okay, so look. How do I differentiate this guy? 2x times dx dx minus 2y times dy dx equals 0.
Then you plug in the points.
Okay, well this one becomes 1, and you can plug in the points, right? This is the x, this is the y. So 2 times 5 minus 2 times -3 times dy dx equals 0. Okay, so 10 plus 6 dy dx equals 0. So dy dx equals -10/6, which is -5/3. Is that all right?
Oh no, example 2.
Okay, so let's get through a few of these examples. Don't fear, but this looks a little different. But that's okay, because you know what? That's a product, and we have a rule for that. It's called the product rule. Okay? So, it says, this is 1 and this is our 2. 1d2 plus 2d1. 1 is, what's the derivative of y?
1.
No, dy dx, right?
Oh.
Well, 1 times dy dx, right? 1d2 plus, what's 2?
Y.
And what's the derivative of
Dx.
our 1?
1.
Derivative of x is
1.
dx dx, or we know that is 1. Okay, all of that was this, okay? 1d2 plus 2d1 plus, what's the derivative of y?
Dy
dx equals, what's the derivative of 9? 0. Okay?
So that first part is just the x, y.
Yep.
Okay.
Alright, so dx dx just cancels because it's 1. So let's plug in now. What's x? 2. Times dy dx plus y, which is 3. All of that. Plus dy dx equals 0. Now what?
That's 3 dy dx.
Yeah, you have 2 dy dx and 1 dy dx. So this is 3 dy dx plus 3 equals 0. So then dy dx equals negative 3 divided by 3, which is negative 1. That tells you that on this equation, the derivative, the slope of the tangent is always negative 1. That must be interesting. Okay? Y'all with me? Yeah?
Never mind.
Okay.
This one?
Oh no!
It's from.
You know what I'll do is I will.
Attention all students invited on the college tour. There is a meeting at lunch today in room 6, Mr. Conde. Attention all students invited on the college tour. Meeting at lunch in room 6, Mr. Conde. Thank you.
Interesting thing is, if you explicitly solve that equation, that is 9 divided by x plus 1. And that graph looks like this. That graph slope is always gonna be, what? That doesn't make any sense. Oh, at 2, 3. Oh, never mind. At 2, 3, the slope is negative 1. Okay, never mind. You guys, what I'm going to do is I'm going to just kind of finish doing the main examples and put it on the rest of this video so that you guys can have more examples before you do the homework. Okay? Tutoring after school if you need it. Good luck on the midterms. Have a good vacation and a good trip.
This part right here.
Yes.
This part right here.